Okay, hey you guys, I'm going to deviate from the normal explanation because I found this really cool video about functions. And I mean, by really cool, I mean very helpful and really well explained with graphics and not so boring and not too boring and not too little information. It's a really good video. So I want you to do this first before you go further in these notes. Okay, this is the first bit of notes that you need. If you haven't done number one, I'm actually going to copy this in another link as well, attached to the notes. But if you haven't done it, please go do this first. He explains what functions are. And once you do that, we're going to head on in to the next one. Okay, knowing that a function is a relationship of one-to-one. That sometimes can be a little confusing, especially when they give you a bunch of stuff like this. It's actually super simple. The rule is that every input right here, domain relates to the input. If this is your little function machine, okay, you're going to put it in and it's going to spit out that. I like thinking of functions as machines. Okay, I like thinking of them as like a little machine that spits out, okay, that you put in something. This is your input, and it spits out an output. And there's something you must do to the input in here. So when we put this in, you're only supposed to get one. So look, this is often confusing to people because look, it looks like we have a problem here because x is going to -6, v is going to -6, k, d. Okay, but that's not a problem because look, x doesn't repeat itself. So the thing is you can't, the domain in a table will never repeat itself. This would have been a problem if you would have had two x's and one went to -6 and one went to -3. That's a problem. The domain cannot repeat itself, but here there's nothing repeating itself. Okay, so it is a function. Okay, take a look here. We're in, okay, so this one goes to 1. This one goes to 1. This one goes to 1. Uh-oh, look. H goes to 2. When you put in H, instead of spitting out just a D or just a B, it spits out 2. Therefore, this is not a function. Okay? And if you were to list these as separate points, you could see that H would repeat itself. You would have HB and HD. Agreed? So you can't ever have that situation. All right, moving on. Let's take a look at the second example. You're going to have to be able to tell, this is the first part that was in the previous page. You're going to have to be able to tell whether or not a function is, or whether or not a relation is a function given grids like this or tables. So here, all you're looking for is a repetition of the domain. Did the domain repeat itself? Is there one domain value that's going to two values in the range? And here, nope, it doesn't matter. You really, honestly, it doesn't matter what this is at all. It only matters that this has one answer. So yes, this is a function. Okay, take a look at this one. Okay, 0, 3, 8, -5, and 4. Nothing is repeating. So therefore, this is also a function. Had this been 8 down here, what if they had put 8, 2? Guess what? That would not have been a function because there were two values of the domain with two different values, okay? Or two occurrences of the domain. Okay, here we go. This is the vertical line test. Vertical line tests are great. If you hit the graph twice with a vertical line test, you know you don't have a function. It's just that simple. Okay? Here, this is not a function. I hit it twice. Okay, this one, not a function because I hit that twice. So no, no. All right, this one, not a function. I hit it twice, right here and right here. This one, this is a function because no matter where I draw that vertical line, I only hit the graph once. So this is a yes. Here, is this a function? I can draw a vertical line and never hit anything twice, so yes. Is this a function? no, because look, I can draw and hit it twice. So this is a no. Okay, vertical line test is great. Here's the thing. I know he talked about the one graph that was a parabola this way. And he says it's not a function, which it isn't. I want you to think of, I'm going to try to get you to a point where you're thinking about the x value. Put yourself in this, like imagine yourself here and you're walking along. Okay. You're walking along this and you're walking in this direction. Okay. Your x value tells you how far to go on the x axis, right? Okay. The function of x, f of x, when I say function, you say y. Function, y, function, y. Okay. Just do it. Okay. Function of x is equal to y. Seriously, that is the same exact thing. So the function, okay, of x is basically saying, like, what is y? So look, if I tell you that you go out here and you're supposed to go on the graph. So here at the x value, do you realize you're not on the graph? It's nice to think of this as, I'm trying to think, what in life is this like? Not really anything that I can think of. Not even a skater actually has that kind of curve. No, I don't really think of it, but I'm thinking you're not on the graph yet. You see that? So let's say I told you to go out to X. You have to get on the graph, you have to jump up to get to here, or you have to jump down to get to here. And there's two values, therefore that's not a function. But I want you to start thinking of graphs a little differently. I want you to start thinking about that. It maps the X and you get to the Y to get on it. We're going to start thinking a lot about functions as like roller coasters or hills or things you can get on top of, stairs, whatever it may be. Okay, suppose that the relationship, okay, now we're going to do domain and range. Sorry, started reading it before I read that from ordered pairs. It's very, very simple. Domain is input, and that's in the X spot. Range is output, and that's in the Y spot. So what is the domain? It says, suppose that the relation T is defined as follows, and then it gives you a list. Give the domain and range of T. Write your answers using set notation. Okay, you will choose these pretty little brackets. That is set notation. Okay, and you will put domain equals, I'm sure they will have it like where you pick domain equals, and then you list the values of the X. Typically, we put them in order, not in the order that they were given, but in the numerical, like in value, like lowest to highest. That's your domain. Range is N and 8. Okay, we don't put two N's because it's already listed once. You don't need to repeat it. Okay, so it's pretty simple. Take a look at the next one, evaluating functions, linear and quadratic or cubic. First of all, let's make sure you know what that is. Linear means that, get rid of that Y, sorry. When I say function, you say Y, function, Y, function, Y. Okay, so here we go. Ready? When I say function, here we go. There you go. The f of x is equal to, say, mx plus b. Let's say 2x plus 1. This is a linear function because it is a line. See the word line in there? A quadratic function is like this. Quadratic, quad. What does quad mean? There's so much power in words, you guys. So much power. What does quad mean? It means 4. Wow, look, you guys. How many sides does a square have? 4. X squared plus 2. You don't have to have the 2. You could have 2x. You could have whatever. The point is that it has an x squared. Get it? It has x squared. A square has 4 sides. 4 is quadratic. All right, the last one, cubic. F of x is equal to x cubed. Okay, this is a cubic. Okay, cubic, meaning if you think about it, okay, how many dimensions does a cube have? It has length, it has width, and it has height, whichever way you decide to do that. I probably did that a little weird way, but it has 3 dimensions. 3 dimensions. How many dimensions does a square have? 2. How many dimensions does the line have? 1, just length. That's where all of that comes from. All right, so here we go. I'm going to erase that, my little cube. Okay, it says the functions f and g are defined as follows. So here you go, you guys. This is always going to match this side. Okay, that little x, this doesn't have to be x. Sometimes I wish they would just do weird things like h of v is equal to v squared plus 2, just so that you understand that h is a function of v. Get it? Okay, these two variables match because they're saying, hey, you're going to plug in v, and it is going to spit out h of v. See, this whole h of v is equal to that. It's going to spit out h of v. Okay, so let's just, that was my little diversion. Come back. Here we go. F of x equals 3x plus 2. This is just plug it in, plug it in. It says f of negative 7. So which one are you going to plug it into? Are we going to find f of negative 7 or g of negative 7? Well, it says f. They match. That's the one you're going to plug it into. So we're going to write f of negative 7. And look, the x replaced with a negative 7. And that's what we do. So f of negative 7 equals negative 21 plus 2. F of negative 7 equals negative 19. In other words, when you plug in negative 7, the function machine spits out a negative 19. Okay, let's take a look at this one. It says g of 3. Ooh, we're going to plug it into here. So g of x, I think I'll change colors because why not? G of x is equal to negative 4x squared. Ooh, this is a good one. You guys, that negative, make it red. Nuclear bombs going off. Nuclear or whatever, like sirens going off. That negative is not part of the base of the square at all. Only the x is squared. Okay, so when we plug in g of 3, and I just changed colors again, but whatever, we will be fine. The base of the square is 3. Put it in parentheses and you won't screw up, I promise. Okay, g of 3 equals PEMDAS, do not multiply until you square that, equals negative 36 minus 3 equals negative 39. In other words, when you plug in 3 to the function g, and you have this little function machine here, like, this is some weird old machine. It's called g. And in g, you have to do this. And you put in something into g, and it spits out that. So if you put in a 3, it's going to spit out a negative 39. It's the idea. All right. Next one, variable expressions as inputs of functions, problem type 1. Okay, so now you are going to be plugging in. This one can be a little tough. Not because it's hard, but because it's like the first time you've seen it. After you've seen it a while, I promise you it doesn't feel so weird, but it's going to feel really strange in the beginning. So you're going to have to trust your method. So here's what I recommend you do. It's saying, here's the function f. F is this. Then it says find f of a minus 1. Okay, so look at what happened. Instead of x, now we have a minus 1. That literally means you are going to plug that binomial, that big old thing, in for that little old x right there. So you are going to go 7 plus 2 times a minus 1, because that's where x was. All over 3 plus a minus 1. And I put it in parentheses just to kind of highlight that fact. Whenever you have addition, though, We don't need that, correct? There's nothing to do there. There's a 1 outside there that's invisible. It would multiply, it would get out of parentheses. We would be concerned if that were negative, but it's positive. On the top, we're going to distribute. And you're going to get 7 plus 2a minus 2 over 3. I might as well just do it, right? Combine like terms. 3 minus 1 is 2. 2 plus a. And then we get 7 minus 2. Combine like terms. 5 plus 2a over 2 plus a. Oh, Miss Baca, there's an a. Can we cancel this? No! Don't do it, people. Don't do it. Can I cancel this? No! Don't do it. Do you see this plus here? Do you see this plus here? The only time you can cancel any common factor is when it's multiplied. For example, if you have 2 plus 7 over 7 plus 1, what's the real answer to that? 2 plus 7 is 9. 7 plus 1 is 8. Correct? That's the correct answer. What if you decide to be a goofball and then cancel the 7 with the 7? Your answer would be 2 over 1. That is so wrong. No, don't do it. Don't do it. All right? So here's the other situation. The only time you can cancel, just so you know, and I'll do it here. The only time you can cancel is when you have like 2 times a over 3 times a. Yes, you can cancel there because it's a common factor. It makes a lot of sense. It's an equivalent fraction. Don't do it here. Don't do it. You're going to do it. There's going to be like 5 of you that are going to do it. Don't do it. Okay, here we go. Evaluating a piecewise function. This one, for some reason, usually people perceive it as tough until they figure out the trick, and then it's super easy. So this, first of all, we haven't even talked about this interval notation yet. It's interesting that they brought it up, and I know I teach it, but I thought it came, hang on. Interesting. Okay, we haven't even taught this. I haven't taught this yet. You don't need to worry about it as of yet, but basically it's saying that this interval starts, for those of you that do remember this, it means it starts at -2 and it goes until almost 2. If I were to graph this on a number line, this might be easier graphed on a number line. It's saying that this could be any number between -2, it could be -2, and any number all the way up to 2, but not 2. Okay? That's what this is saying. Is that important to the problem? Not really, like really not really, because they're telling you what the function is here anyway. This is the most important information. So here's a function that has multiple outputs for different inputs. So here's the thing. Read it like this. Here's the function g of x. Okay, if you plug in, the function of g of x is equal to -2. When? If x is between -2 and -1. So for any value between -2 and -1, g of x is going to be -2. For any value between -1 and 0, less than 0, but greater than or equal to -1, it's going to be -1. Any value between 0 and 1, it's going to be 0. It's basically telling you, like, hey, if you meet these parameters, then this will happen. Like, if you are tall enough to ride this ride, then you get to ride the ride. If you're tall enough to ride the next ride, you get to ride whatever. The point is that all you're trying to figure out is what they're giving you. So this is the definition. Here's the problem. Find g of -2. So you're like, ooh, which one does g of -2 fit into? So you walk up here and you look here and you're like, Which one is -2? Okay, see, -2. X is greater than or equal to -2. It's this case. So G of -2 is -2. It told you if it's -2, it's -2. If it's between here, it's -2. How about G of -0.75? Well, 0.75 on the number line is not quite at -1. So it is greater than -1, right? So it is here. Well, if it's here, then the value of G is -1. So G of -0.75 is -1. And G of 1, look and see, where does it fit? Here it is. X is equal to 1 is 1. So G of 1 equals 1. All right. Finding outputs of a two-step function with decimals that models a real-world situation, function notation. Okay, basically you're going to be dealing with moolah, money, 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 because decimals are always money. In fact, if you're ever having trouble with decimals, think of money. Money's great for that. Okay, Mai received a $30.50 gift card for a photo center. She used it to buy prints that cost 6 cents each. The remaining balance, B in dollars, on the card after buying X prints. In other words, she bought some number of prints for 6 cents each, and then she's got so many dollars left, is given by the following function. Heck, you didn't even have to come up with a function, people. She started with 30.50, and she's going to subtract every print that she's had for 6 cents, right? That she bought for 6 cents. Here it is. What is the remaining balance on the card if Mai bought 50 prints? Basically, you're just asking what is B of 50? It means plug in a 50. That's all. 30.50 minus 0.06 times 50. Okay? I don't know. Sorry. I should get a calculator when I do these notes, but I don't. So I'm Sue. Okay, 3, correct? $3? Think that's right? Tell me if I'm wrong. Right? 50 prints times 0.06. There's 2 decimal places. I multiplied it. It doesn't really matter that that's going to be 0. Who cares? It's just the same. And you move it over twice. It's $3. So B of 50 is equal to $27.50. That's how much she has left on her card. Wow. She can get lots of prints for 6 cents each. All right. Take a look at the next one. Finding inputs and outputs of a two-step function that models a real-world situation. Function notation. All right. Lucy wants to save $900 to buy a TV. She saves $18 each week. Oh, wow. Okay. The amount A in dollars that she will need after W weeks, they're giving you that, is given by the following function. So look, they're even telling you that A, okay, the amount that she still needs is going to be a function of the weeks that she saves. That's what that notation means. It's giving you a lot of information right there. They're like, oh, the amount is dependent on the number of weeks. Okay. And she needs 900 rather, and she saves 18 each week. That's what that equation really means. If Lucy still needs $558, how many weeks has she been saving? So, where do you plug that in? Which variable is this one? Okay, that's the amount that she still needs. So you're going to go 558 is equal to 900 minus 18W. Subtract 900 from both sides. 342. Okay, so negative 342 is equal to negative 18W. Divide both sides by negative 18, and you get 1. W is equal to 18 goes in. Seriously, y'all, you're going to get good at basic math by watching me do all these problems. 14 minus 8 is 6. 2 minus 1 is 16. 162. 8. 18 times 5 is going to be 18 times 6, 7, 8. About 9. That ends in a 2. That's how you know. Ends in a 2. It was a good guess. So 19. All right, 19 weeks. That's the answer to that one. All right. So 19 weeks, and you would answer it there. How much money does Lucy still need after 5 weeks? So they're giving you the 5 weeks. So that you're going to plug into there. So A of W is what you say in English for this. A of W, or the function A of W, okay, is equal to 900 minus 18 times 5. 900 minus 5 times 18 is 5 times 20 minus 5, which is 95. 800 and, ouch, okay, $805. No, is that right? Why am I having trouble? Okay, yes, that's correct. Okay, A of W. Okay, so she would still need $805. All right. These ones aren't so bad, right? If they give you sometimes the hardest part is coming up with the equation. They give you the equation, you're like, woot, I'm in a good situation here. Okay, domain and range of a linear function that models a real world situation. All right, a lot of times the domain in real world, you might have a line, for example, you might figure out a line and it goes like this, okay? But the negative part makes no sense in the real world. Like, for example, if you're talking about, let's say you can make, like 20 cookies per 1 cup of flour. So you'd have 1 here and 20 here, right? And then 2 would be 40. So if you had 3 cups, you could make 60 cookies, right? Okay, well, that's great. But you can't go in the negative zone because that's just dumb. You can't have negative 1 cup. Okay, it only makes sense in the positive. So a lot of times the domain is kind of about common sense stuff. So just be on your lookout for that. A construction crew is lengthening a road. Let L be the total length of the road. That's usually on the left-hand side. In miles, let D be the number of days the crew has worked. So do you guys see how the length is going to be dependent on the days, not the days dependent on the length? So suppose that length is equal to 2D plus 300. And that gives a function L. It gives you function L gives L as a function of D. Oh my goodness. So in other words, the length is dependent on the number of days. We're going to plug in the days first. The crew can work for at most 90 days. At most, okay? Identify the correct description and the values in both the domain and range of the function. Then for each, choose the most appropriate set of values. All right, so if we're looking here, it says the domain is the length of road in miles or the number of days the crew has worked. Okay, unfortunately, I can't do this, you guys, but I am going to assume that it's going to give you something greater than 90 days. So your value in here has to be between 0 days and 90 days. Okay, that's what makes most sense because they can only work 90 days and 0 is going to be the lower end. Okay, the domain is right here. It's D. It's what you plug in. The domain is always what you plug in, okay? And it even says the number of days the crew has worked. So that is your domain. The range is the length in road, and they're going to pick that, okay? So what would make the most sense? You guys ready? This is what you do. You plug in to figure that out, okay? You would have to plug in the highest level and the lowest level, because that's going to tell you the output for each of these. So if I plug in a 0, what would be the length of the road? it's going to be just 300. In other words, that's what they're starting with. They're starting with 300 miles. It's already there. Okay, so then, okay, we're going to plug in the 90. So 2 times 90 plus 300. That's 180 plus 300. And now we're going to get 480 miles. Okay, so this is going to be your range. Your range is going to go from 300 to 480. The problem is I don't know exactly how they're going to say that. Are they going to put it in? I don't know with Alex because I can't access this. I don't know if they're going to do this, like put it between, or if they're going to put it in set notation. But just know that that's what you do. You take the lower limit and the upper limit and you plug them in, and that'll give you your range. All right.